Hello, it's my pleasure to welcome Alyssa Batula. She is a data scientist with an engineering background, and she's going to talk about data science and Agile. Let's give her a round of applause.
Hi, everyone, and welcome to my talk where, I'm going to talk about Agile and data science and some strategies for maybe helping them get along a little better. So a little bit about me and why I'm here giving this talk. I started out as an electrical engineer, and so as a student there was zero Agile. I'm not even sure I'd heard of it at that time. But then I got my first job. I was hired as a software engineer by Cox Automotive. And while I was still doing data science type work, I was on an engineering team, and that's where I really learned about Agile. From a team that was really invested in it, taught me a whole lot about how something like that can really work. And then I transferred in the same company, but to a data scientist role, and it gave me a different perspective on Agile. I got to see how a different type of team interacts with it, how a team of all data scientists can interact with Agile, and some of the ways it can help and or hinder depending on how it's set up. And then a little bit on my experience and my biases. I am familiar with Scrum-like Agile frameworks, so all of my examples and my terminology is probably going to reflect that. That doesn't mean it's exclusive to that, it's just what I'm most familiar with. And similar with data science, my specialty is machine learning and AI, so my examples will reflect that, but it still applies if you're doing something more like business intelligence or data analysis. So as you'll see throughout this talk, misunderstandings between different people in different roles is a big hurdle, and so I want to start with just a little bit about what is data science. So data science is supposed to create business insights and help make better decisions, to tell a story about your data, or sometimes they'll say find the story that the data is trying to tell. There's a lot of subfields of data science, so if you hear someone talking about data analysis, business intelligence, machine learning, AI, they're all data science related fields. And then finally, because it's data science, they use data, statistics, and programming to do their job. And I'm going to highlight data a few times because without data, there is no data science. So in a lot of ways, data science is kind of like engineering. Both fields require strong problem-solving skills. You have to collaborate with product and the business to figure out what exactly you're supposed to be doing. At least sometimes with data science, you write code to build a system or a solution to solve a problem. And also, sometimes for data science, you can use engineering practices to build that final solution. But it's also very different from engineering. So here's that data again. Data is number one to data science. Mainly because they need access to this data to do their job. And when I say access, I don't mean access to sample data or example data. I don't mean in the final production code, you'll be able to access the data in production. I mean the actual human needs access to the data. And it may sound like I'm harping on this, but a lot of problems I've experienced is groups not understanding that distinction, that it's not enough to give production code access to your database. You have to actually give the people access to go through and look at it and analyze it. Data science also focuses on knowledge. They want to deliver insights to the business, help them make decisions. Your deliverable might not be at all a code solution. It could be information to help the business make a better decision. So there's not necessarily a code base involved depending on the type of work you're doing. There's also a much bigger focus on correct statistics than there is on coding practices, and a lot of this is about backgrounds. I have a more engineering background than a lot of data scientists. A lot of them are coming from math and statistics, and so they'll have backgrounds in how to make sure you're not lying with statistics and how to make sure your final numbers are correct, but a lot less experience with things like how do you unit test your code? How do you write code that's maintainable? There's nothing wrong with this, it's just that those aren't the particular strengths that they are bringing to the table. They're bringing usually the math and statistics and probability. And then related to it being probability-based, as will come up later in the talk, 100% accuracy with data science is just not a thing. And that'll come up at least once, but it's just keep that in mind, it's probability-based. You're looking for the overall performance of things. And then the type of tasks data scientists tend to do is different. You might ask them ambiguous questions or open-ended questions or really research-oriented tasks. And the one people don't always like to talk about is the projects might fail. You could put months of work into something to come to the conclusion that you don't have the right data to solve this problem. And that is unfortunate, but it's fine. It's just a fact of data science that it could fail a lot more often than you might expect a software engineering project to fail. And just a little bit more on that ambiguousness, if we have a sliding scale from this is something that is standard practice, we can predict it, and we know we will do it, to this is very mad scientist research, it's unpredictable and it might fail. Engineering can span that, but it tends more towards standard practice in a lot of jobs. You're building something that is at least tangentially related to something that's been done before. Not that you can't do something more experimental and exciting, but it's just a little less common. Whereas data science can really span this whole range, and the problems with Agile really come in when you get into this side over here, where you're doing something really new and unique, and you're not really sure how to fit that in. So one last note on data science is how we evaluate it. It doesn't really have a binary pass-fail criteria. You can't just run a bunch of unit tests and say, okay, they passed, this is definitely good. If you're doing analytics, you're going to have subjective metrics, like is the information useful? Does it help us make decisions? Or maybe there is code involved. You've written a machine learning or predictive model. Then you might be interested in how well does the model predict things on average? And I want to highlight that on average part because, as I mentioned before, it's probability-based. You're interested in overall, how does it perform? Does it get most things right? I like to think of it as occasionally being wrong is the price of using something like a predictive model, whether the benefit is a speed up or some kind of cost savings, it's always some kind of trade-off. So I've talked a lot about data science, but Agile is really important to this talk too and understanding it. And I found two parts of the manifesto particularly useful for trying to integrate data science. So focusing on individuals' interactions over adhering to processes and tools, and then responding to change versus being really a stickler for your plan. And then some of the principles that I also found helpful are things like, requirements are going to change even more often in data science. As you're working through a project, you might find something that you're going to have to change what you're looking for, change your plans. Working together is so important. Having people understand what's going on, being able to communicate. Everyone doesn't have to know how to do data science, but the more everyone understands what the role is like and what to expect from it, the smoother things are going to go. You need some way of measuring progress. A lot of times that's working software. For data science, I would say maybe information sharing is a measure of progress. And then just always being open to reflecting and changing your processes, because data science is so new to the Agile world that we're still figuring out best practices for how do we integrate this, how do we get these things to work together, that it's going to take a lot more iteration than a software engineering team would to get things running smoothly. So the background's out of the way. So now I want to get into some of the common complaints about Agile and data science that I've heard from various perspectives, whether it's been data science complaining or a Scrum master having issues with something. And I also have a bunch of case studies, I like to call them. They're all real-world examples. So I changed the details to protect the innocent, but I didn't make any of them up. They're all based on real conversations I've had with other people or things that I personally have experienced. So complaint number one comes from both sides of Agile and data science, is the data science doesn't fit. If you use sprints, it doesn't fit into your sprints. If you're trying to write stories for data science, they're too big, you can't break them down, they're hard to estimate. A data scientist will say, you want me to finish something in 2 weeks? That's not a thing. You can't do research in 2 weeks. They can also feel pressure to commit to timelines. And I mean, data scientists don't not want to commit to timelines out of spite. It's usually because they truly don't know. Like, they've never done this before. They don't know how long something's going to take. So a really great solution is change your definition of a deliverable. Maybe you're not looking for a specific, a feature to be done or the code to do something in particular. Maybe you're looking for information update, a status update. What have you tried? What has been successful or not successful? Using a lot of research spikes can go along with this. Like, maybe if your business is really into, we have to have something done every sprint, use a research spike, and at the end of that sprint, get a little update summary, and then create a new research spike for the next sprint. And that type of thing also helps with communication, keeping everyone in the loop, so no one's like, what are those data scientists doing over there? What have they done this past month? Another option I've heard a lot of people suggest is just, if you can, use Kanban or Scrumban. Just let them work on the thing until it's done. Maybe add some progress updates, but just kind of accept that that's the way it's going to be. And so this brings me into my first case study, and this is actually about my very first job, one of my first weeks at that job. So there was a brand new project at my company. They wanted to build an image classification system. And so just imagine there's a bunch of images coming in. We want to know, was that a picture of a cat, dog, cheetah? We want to identify those things. And so I get asked, what can you commit to getting done in one sprint? And so I am new to Agile. I'm new to this project itself. This is my very first job out of school, and I really want to keep this job. And so all of my experience as a student and in engineering is like, you have to undercommit. If you overcommit and underdeliver, that's the worst thing you can do. So I really limited myself and was like, I can probably identify one thing. So just like one versus everything else. I can tell you if it's dog or not a dog with like maybe 80% accuracy, do an okay job of it. And I mean, it worked, and the project moved on, and this wasn't the failure of the project. But it slowed things down because I limited myself and said, we're just going to focus on this one tiny thing that I know I can do. If I were to go back now, I would have said, I'll train a model, and I have no idea what it will do, but I'll come back to you with results, and we can talk about them and where to go. And it's just one of those things that if I had done this, the project would have been, maybe a couple weeks faster. But as you add on, doing this type of thing every sprint, it could really speed up a project the more you focus on this type of deliverable versus, I can get this working code. Related to planning, but more long-term planning now, data science projects really are hard to plan. Like, you could be, you're trying to do your backlog, and you don't know what step number 3 is because you need to know the result of step number 2 before you can even decide where to go from there. Like, they're kind of branching stories that depend on what work you've done before. There's also a lot more delays or setbacks, or the really unfortunate example, a month into the project, data science is like, this is not going to work. We don't have the right data. So one way around this is just, if you can, just accept your limited ability to plan. Plan 1 or 2 iterations out, and then just say, that's it. That's as far as we can go until we get new results. Another option, and this is one I like if something is like really researchy and you're not sure what to do with it, is just give the data scientists, say, a month, a quarter, however long, and say, go do a proof of concept, do your data science thing, and then come back to us and tell us, is this something we can do? And once you have that baseline of like, this should work. Then you can take a more agile approach and start really planning things out and what kind of work is going to be needed to get this into production. Another complaint is just how siloed data scientists are. Whether that's your data scientists don't understand the business goals, or data science and engineering don't understand each other, and so that's going to make things really hard to get something into production once it's done. Or maybe the agile and product roles don't understand how data science works and they're not sure how to work with them. So really the only solution to this is communication. Keep everyone communicating, talking about progress, goals, what you're trying to achieve, and then making sure everyone understands the purpose of everyone's roles. Like, why is this person asking me for this? Why are we doing things this way? Because one thing I've really found is that integrated teams do better from talking to different people. Product owners who understand data science can really help drive the project. If they know what data science is doing, they can help facilitate communication, be that kind of go-between who understands enough data science to talk to the rest of the business or to the software developers who have to deploy something, and then vice versa, tell the data scientists why engineering needs their output in a particular format in order to use it. Related to that, just any facilitators, you really want to be able to handle data science. You really don't want to be in a position where your data scientists or product feel like that facilitator, whether it's a Scrum Master or anyone else, is a bottleneck because they're just kind of parroting questions and answers back and forth rather than really understanding what's going on, and they can have a useful conversation. And then just better collaboration will help get the product into the right hands. If there's any kind of initiative to smooth out the process of getting, say, a predictive model into production, getting a team of software engineers who's used to working with data scientists or data scientists who are used to working with software engineers, that will really help smooth things out. My second case study here is I was talking to people and I found that there's 3 pretty similar projects. And so imagine a scenario where business wants data science to come in to an established software engineering project and automate some portion of it. A problem that comes up fairly often is, this is an established project. The engineering team is rightfully protective of this thing that they are responsible for supporting. And maybe they're also protective of their data. Maybe it's proprietary information and they've never let a human dig into this database before. It's only for the code to use. And so the first project was not even an Agile project. There was really no one to help with that collaboration between the teams. And what happened was the project failed. They could never come to that compromise of this is how we're going to work together. There was a second project that I heard about. It was an Agile project. And it took a little while, but they were able to work with product and Scrum Masters to get the 2 teams aligned, to understand why each team needed what they did and worked the way they did, and they found a compromise so that everyone could do their job. So that one eventually succeeded. The third project, which is the way I'd recommend going about this, is they didn't even let anyone start on the project until they had sorted that out. It was like, okay, if you want us to do this, you're going to have to promise us access to data. You're going to have to promise us support for X, Y, and Z that we're going to need to do this. And so by doing that, they skipped a lot of those headaches, and you didn't have a team kind of twiddling their thumbs because they were waiting for data access or anything like that. Another complaint that I've heard is that Agile has too much overhead. There's too many meetings that take away from that heads down work time, or updating stories and doing backlog work is a lot of busy work. And a lot of this comes down to data science really not understanding the Agile process and what it's meant to do for knowledge workers. So making sure that everyone understands the value of these meetings and knows what they can get out of it if they go in good faith and we're really ready to work through things. Another really good thing to focus on with data science is they might not understand how much you can help protect their time and help them prioritize their work. And an example of that, when I was talking to a Scrum Master, they were tasked with trying to transition this data science team to Agile, and they got a lot of pushback. They thought that Agile was going to take up too much of their time, and they were already so swamped, how are they going to add this on top of it? But what they found as they started working together is they were already losing so much time to try and self-manage. One thing that is probably not exclusive to data scientists, but they'll sometimes get those surprise requests, an email like, hey, could you just look at the data and tell us if X, or hey, can you get us just a really quick proof of concept? And these things can sometimes snowball, and then there's also that context switching of whenever you're switching a project, okay, now I have to go figure out what's going on over here and forget everything I've been working on for the past week or month or whatever. And so the Scrum Master's goal was to show them how much they can really help prioritize what they're doing. And then my final complaint that I want to talk to you about today is, I call it a metrics disconnect, and it goes both ways. If you're using a form of Agile that uses metrics like sprint velocity and things like that, it's not going to be meaningful to your data scientists, and they're not going to really understand how it relates to their work. It's very difficult to get things like that to relate to what a data scientist is doing. And then going the other way, the data science metrics can be hard for stakeholders to understand. That idea that a project is successful even if it occasionally makes an error or isn't 100% accurate can be really hard for people to understand if they're used to, well, why didn't you just test that input as a unit test, even though that doesn't work for things like machine learning. So really focusing on metrics that measure the true process from an Agile perspective. If you need those metrics, find a way to make them work with data science. Or abandon them entirely. Maybe they're not that important to your company that you can just say, okay, we're going to ignore sprint velocity for the data science team because it's not helping anyone. And then also work with data science to set expectations. That is one of the things at my first job. I probably spent my first couple weeks just talking to people, explaining, like, this is how data science works, this is what you can expect. I did a lot of talking with especially our QA testers on this is how you can approach testing a machine learning model and how that's going to be different from what you expect. And it took some time, but it was absolutely worth it because, after not too much time at all, the whole team was really on board, like, yeah, this is how we test this and this is how we measure how it's going to be successful. And so my last case study on humans versus the machine, as there always has to be, there was a project to automate data entry. And it was a good system. It was over 90% accurate. Sometimes for some categories, I think it was even like close to 100, but not quite. But they kept getting this pushback, like, hey, last Tuesday it got this one wrong. Can you fix that? What's going on here? And there was a lot of back and forth with what I've mentioned before of that's not really how this works, but we really want to get this right. And so there was a lot of digging and conversation. And what they eventually found out was happening was two things. They assumed that the humans who were doing data entry were always 100% accurate, no typos, no mistakes. And then they were comparing the AI system to that presumed 100% accuracy. But when really the case was like, humans make mistakes too. It's what we do. And so what they really should have been doing is comparing how often the machine makes a mistake to how often the people make a mistake, and then factoring in the time savings. Like, it's faster for the machine to do it. Is it worth a couple extra mistakes a week? Maybe, maybe not. It's going to depend on your use case. So, some final thoughts before I end my talk, and to just summarize some of the strategies that I found helpful. So, I want to highlight how Agile can help data scientists to try and get around all that complaining of, oh, I don't want to do Agile. Some things you can highlight to a data scientist would be just protecting that heads down time. It is super important to data scientists just as much as it is to software developers. But if they haven't been taught about Agile, they might not realize that this is a benefit. Helping people know what they're supposed to be working on, protecting them from random surprise requests. And then also that faster road to production, or getting their results into the right hands of people who need to see them. Integrating better with whether it's business or engineering, whatever it is they need to get their results out there. Because it happens more often than we like, and it's always disappointing where you put a lot of work and effort into something and you have this finished product, but there's not support from engineering to get it into production, or you don't have access to the right business people, or they don't understand what you're talking about. And I mean, no one likes for their work to put a lot of work into something and be like, oh, this is not actually going to be used. It's no different for data science. And then some strategies from Agile for how to accommodate data scientists better. You could try, just accept the limits on your ability to plan, go in with some workarounds. Adjust your expectations on deliverables is a big one. That understanding that it's knowledge, you're trying to deliver learning new things versus just working code. And then facilitating that communication understanding. A data scientist is probably not going to have learned anything about Agile from, say, a computer science class or anything, an undergrad or maybe even a previous job. So just understanding there's going to be a little more learning from a data science team probably to get them on board. And then just not expecting them to be software engineers. There's a lot of similarities that you can definitely make use of, but there's also some differences to remember and be aware of. And so finally, I'd like to thank you for coming to my talk, and I'll hang around if anyone has any questions.